The last couple videos that I made surrounding the Aptos ecosystem were largely for retail consumers to get started, spinning up a wallet, staking some apt, and then exploring some of the things that there are to do in the ecosystem. But Aptos, in particular, one of the biggest reasons that people are using it are because of the Move virtual machine. Developers like the developer experience when developing on Move, developing for Aptos ecosystem. So what we're focusing on in this video is what does it take to actually get started developing things like smart contracts for Aptos. So one of the cool things that Aptos did here is they actually made a transition guide. If you're coming from Solana, which a lot of us that are following me are, here's a similar way that you can take a Solana smart contract, a Solana program, and rebuild it in Move and deploy it to Aptos. So I spent some time actually digging into this, learning some of the nuances, and I want to show you how you could get started at least exploring the Move VM and what it's like to develop smart contracts on Aptos. Let's check it out. So here's what I want you to do. I want you to go to learn.aptoslabs.com. This is really a one-stop shop to help you get started developing both front-end applications as well as the back-end smart contracts. They specifically call those modules. So developing modules to be deployed to the Aptos blockchain, that's what we can do right here on this website. Now, considering that my audience is largely going to be coming from Solana, perhaps you've already watched my Solana developer training, there is this one guide right here that really stood out to me. If I zoom into it a little bit, let's go a little bit bigger. Building on Aptos, a guide for Solana developers. So this naturally attracted me. This is what I was like, oh, I can already, do Rust programs. I know how to understand what Solana's got going on. And it does do an okay job of comparing a Rust program to a Move module, but it doesn't actually show you how to do things like build it, compile it, publish it, and test it. It's just a side-by-side code example. Nonetheless, the reason why I really like this is because there is an advanced implementation. When you think about Solana development, one of the big things that makes Solana development is PDAs. In other words, any old user can connect to your website and their specific user data is stored underneath their PDA. We get that, right, as a Solana developer. So that way multiple users can interact with your application and store their own user-specific data under their own user-specific PDA. This is if you've been in Solana development for a while, this is still one of the early things that you have to learn. But nonetheless, it's an advanced topic. And this particular tutorial right here actually gives you the option to implement something similar. And that's why I was like, I don't want to do Hello World. I want to jump straight to something that is real, where users can store user-specific data. The comparison here in Move is they call these objects right here, and the user-specific details are stored under a user-owned object. So the user will connect to this application. It'll create an object for that user, and then the user's data is stored underneath that object. It's the exact same concept, just a slightly different terminology. Now, again, the big thing here is it doesn't really walk you through, it walks you through the code, but it doesn't walk you through how to use it. And that's the big reason why I'm actually making this content. So the first thing I would say right here, if you're on this page, give it a view on GitHub. We'll jump over here to GitHub, and we see it is 0x_Aptos/Solana2Aptos. So we'll go ahead. I'm going to clone this right now. We're going to start off fresh. You'll get to see me do this from scratch. Zoom in a little bit. I'm going to move into my code folder. I'm going to make a directory here. We'll call this, Aptos work or something like that. Change into Aptos work and give it a git clone like so. Now, what do we need next? What we need next is the Aptos CLI. That's a very important piece of the puzzle. So let's go ahead and get the Aptos CLI installed. It's actually very easy. If you jump back here to the Building on Aptos, a guide for Solana developers, click on the to-do list demo right here. And right here under the prerequisites, hit it with set up your environment. Now, for the most part, you really only need the Aptos CLI here if you just want to build it, compile it, push it, and run. If you also want to interact with it, I recommend getting a good IDE. I use VS Code, as it indicates right here, with the Move syntax extension. But it is pretty cool that they do have the free version of IntelliJ has a Move language plugin that you can use that tool. That's just cool in my opinion. We actually don't need any front-end development for this, so you can actually ignore this second piece right here. We're not going to do any Aptos SDK in TypeScript or anything like that. This is really just focused in on understanding Move and what it's like to build modules, publish modules, and interact with modules. So go ahead and pop up the Aptos CLI right here. Depending on the your operating system, you've got Mac, Windows, and Linux. Mac is very simple. It's just brew update, brew install Aptos. That's it. Now, I've already got this installed in my environment. If I give it a brew upgrade Aptos, it'll check to see if there's any new versions and install it if so. There's not any new versions, so I'll just let it spin here and come back to it when it's done. Sure enough, Aptos 3.1.0 is already installed. Great. So looking at my environment, I'm going to move into Solana to Aptos, give it an LS. I'm going to move directly into Aptos. Now, don't worry, I'm going to show you some of the Solana stuff too and what this repo looks like. I'm going to give it one more LS, and now I'm going to move into Advanced To-Do List. Remember, the reason why we're doing Advanced To-Do List is so it gets user-specific objects, and users can store their own data underneath it. That's different from Simple To-Do List, which is where one person is connecting and they just basically own the smart contract and they can write their own to-do list, but nobody else can. There's just one and done. It's basically what it is. So with that being said, I'm now in Advanced To-Do Lists on my terminal. The final thing I need to do here is get VS Code up and running and opening this folder. So we're going to navigate to that code, then Aptos work, Solana to Aptos. I'll hit open right here and we can start checking it out. So if we look at this, the reason why this is really cool from a Solana to Aptos is they're the exact same smart contract. They do the exact same thing. It's just the ability to create a to-do list, create items on the to-do list, and then mark them as complete as well. Basically 3 write operations: create the to-do list, create the to-do, complete the to-do, and then some view operations too, if you actually want to, get data rather than write data. So if you look under Anchor, Programs, Source Code, and of course, starting with lib.rs, you can start to see where we enter the program, initialize the program, and then as well as the entry functions, which kind of, identifies what we've got here. So in this case, we have the to-do list counter, which is a PDA that keeps a count of to-do lists. And then underneath that, we can create the individual to-do list, which belongs to the PDA, the to-dos, which belongs to the to-do list, and then the ability to complete those to-dos. Very simple structure. This is what we're mimicking when we go over to the Aptos section here. So I'm going to go into the advanced to-do list here. And where we start out with is we look in the move.toml file. Now, the first thing to understand is this module needs to belong to an address. And addresses in Aptos look like hex addresses, 0x something. And that's what we're looking at right here when we see this addresses section. In fact, let me zoom in a little bit more so this is a little more legible here. It's kind of a semantic, if you will, where you see the addresses right here for this particular module. This module is going to have the name on the blockchain, Advanced To-Do List ADDR address. And if you put this underscore right here, this is basically saying we're just going to use the same address as the account that is publishing it. So if my address is, 0x123ABC, and I publish it with this configuration right here, the module itself would be accessed by 0x123ABC : then advanced, and I got to write better, advanced to do, blah, 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 it'd be advanced to do whatever. And then after this, the syntax would, or the semantic, excuse me, would be then the function name that you're calling. This will make more sense in just a minute, okay, when we actually publish it and use it and see it on the Block Explorer. But I want you to understand this. This was something that, it took me a little bit to adjust here and understand. When we write modules to the Aptos blockchain, those modules belong to an account. And we specify exactly where on the blockchain that account is right here. And if we don't put anything in this TOML file, it's going to basically be owned by the calling account. So check this out. What I'm going to do is I'm going to flip over back to my terminal. And you see I'm in the advanced to-do list folder. Okay, so watch this. I'm going to type Aptos init. This is going to initialize a new account specifically in this folder. I'm going to point it to testnet, and that will also give me a small airdrop enough to pay my gas fees. So in the advanced to-do list folder, where I'm in Aptos advanced to-do list, I'm going to do Aptos init. It asks me which network. I'll say testnet. I press enter. I don't need to add a private key. It'll generate a new one for me. There we go. Here comes the account, and there's also an airdrop right there. The octas are the equivalent to LAN ports right here for Solana. So flip on back to VS Code, and you'll see now I've got this hidden folder, Aptos, with config.yaml, and I can see things like this is going to be the account that the modules are going to be stored at. When I perform operations on the CLI, like publishing it, it's going to be done as this public key right here. Again, trust me, this will make more sense when you actually see it in action. It's kind of like watching a Guy Ritchie movie right now where there's like 10 different plots going on at the same time and they all converge at the very end and it makes you go, oh, that's what was going on. Okay, anyways. So you could safely copy this account right here, jump to the move.toml file and paste it in right there if that's what you wanted to do. That would be the exact same effect. But I'm going to undo that and just leave it exactly as it is. Now to the smart contract. The smart contract right here is in sources and then advanced to-do list.move. You will see a lot of things in this code that feels like Rust because Move is effectively built in Rust, built on top of Rust, but specifically for blockchains. And the cool thing about it, in my opinion, that Move does, is it is smart. It's intelligent. It can infer a lot of the things that you're trying to do. If you are coming from like Solana development, you know that you have to be very explicit with what you want it to do, even down to the most basic thing like providing every single account that's going to be touched or changed in any type of smart contract run. Here, for the most part, Move can actually infer a lot of that for you. So we start off by defining our structs. Here, of course, is the counter. Like I said, this is what's going to be stored in the object level, keeping track of how many to-do lists you have. Then for the user, they will have the to-do list. Then underneath that, they will have a to-do. And you can see the details here. The values or the keys, we have counter, owner, to-dos. The to-dos are a vector of to-do items right there. It's very simple to understand. So scroll on down, we see some more familiar concepts like the init module. Every time that this function is called when the function is published. If it needs to create some specific data on-chain at the time of being published, this is what it does. There's nothing really for us to do here because the entire point of this is to just bring the contract to life so that when a user wants to create a to-do list and then to-dos, that's what the entry functions are due. As it says right here in our sample code, these are our write functions. Things that I like a lot right here. When I see this one, of course, is going to begin by creating the to-do list, which is really creating the counter. As you can see, the parameter here is, well, this is going to be, if we have the user, they need to create their object, which can then own their to-do list. I'll put TDL for to-do list right here. So this create to-do list is really creating the first to-do list, which also creates the object at the same time. you can see the parameter that it needs is who's the sender, who's the person that we're doing this for. And one of the cool things, again, that Move is able to do is it's able to automatically determine that the sender is the person who signed the transaction. When we actually call the create to-do list function, we don't actually have to pass in this argument. We don't actually have to pass in this parameter because it's able to see, hey, this is just coming from the signer. The sender is the signer. And that's what this reference to signer is actually referring to right there. Now, acquires, right here, this little semantic, this little syntax is a little interesting the first time I saw it. What I first thought this was doing was the return, but it's actually not. This is not the return data type. This is actually referring to the struct that this function will interact with, whether create or query, on the blockchain itself. A big thing about working with Move is very frequently we're looking for a specific value in the structs above that we defined. So what we're saying right here is this particular function is going to work with this particular kind of struct. And below, in the code below, you can expect to work with values that belong to that struct. Now, the code itself is actually relatively straightforward to look at here. We're going to declare the sender's address by finding the signer's property, converting it to a specific address of from the sender. Pretty simple. That's just the method that it's calling right there to get that specific value. We're going to check to see if this user already has a counter in existence. So we'll see if it exists a type object of to-do list of counter for this particular sender. Then we'll get the counter value by looking at the global data for this type of this sender and set our counter equal to the counter value that's on chain. Otherwise, we need to create the to-do list counter. So we instantiate a new struct with a counter of 0, and then this function right here, move to. This basically means write it on chain. So this sender right here gets this counter variable, which is our user to-do list counter struct. So now that they have a user to-do list counter object in their account, it moves on below this to create the first to-do list as part of that counter. In the same way that PDAs need a seed, in the same way objects do too. So we're going to use the object method, create named object, for this center, and we'll call a private function that's declared down below that creates the to-do list object seed. We create the object signer from that object. Then we create our first struct of the to-do list. As you can see, we then write that on the blockchain with move to. The object signer, which is really the object above, which is owned by the sender, is then going to get its first to-do list. And lastly, we increment the counter. Again, you can see we get the specific to-do list counter for this sender, and then just increment the counter like so. So this creates the initial to-do list by creating all of the necessary objects if they don't exist. You scroll down and then you can see some more simple functions to create the to-do. And at this point, it's pretty much the same stuff as above. We find the sender. We derive the to-do list object address from the seed. We get that to-do list on chain by borrowing the global mutable version of it. We create the new to-do item, and then we push that into the vector that the to-do list has. And then lastly, the complete to-do, relatively straightforward again, basically just setting a Boolean record by finding the to-do list item and then setting it to completed equals true. Now, of course, there's read functions too, where we actually have views. These are decorated with the view attribute right here. And the big difference that I want to point out right here is, of course, some return type declarations, as well as the fact that it doesn't infer the sender from the signer. In this case, you actually do have to pass in specific arguments. So the syntax here is, we have a public function. That means we're going to be able to get to it. It is read only because it's decorated with view. It's not borrowing a reference anywhere. So we are going to have to pass in these arguments. And importantly, this is going to have the return value decorated. So when we get the to-do list counter, the specific counter itself, scroll up to look at the to-do list counter. It's going to have a key of counter and a value of U64. That's what it's going to be returning, is that U64. Now it gets that by acquiring on the blockchain the global user to-do list counter. So again, don't confuse the return value with what type of struct it's interacting with on chain. Again, it first checks to see if the to-do list counter exists for the given sender. If it does exist, we're going to get that data from the chain by borrowing global, and then we're going to set and return counter.counter right there. Basically, the counter value of the counter object that we borrowed above, which, as we know, is a U64. Otherwise, return 0 if it doesn't exist. There are no counters for that user. So at this point, you should be able to kind of read through and understand what it is that this is working. And again, the simplification of how this move code is actually very clean and very easy to understand compared to, if you're coming from the Rust world, that is. Okay, cool. So how do we actually use it? This is definitely where we start to deviate a bit from what we see in this, guide that we have right here. If you were following along in this Aptos Learn guide, it'll show you, and describe to you in comparison, what is it like to work with the Solana functions and methods versus the Move ones, but it doesn't actually show you like how to build, deploy, and test. So that's what I'm here to do. What we're going to do in the advanced to-do list folder, we've got, the code. Of course, the hidden folder already has my profile there, where we initialized an account and got some testnet octas sent to us. We're going to do Aptos Move Compile. Now, flip on back here to the code for a second. In the move.toml file, we did have these addresses and these dev addresses. I'm not really interested in doing any dev builds, so I'm just going to nuke this, and we're just going to focus on deploying to the given address right here, which is going to be my default address. When we compile this, we do have to specify, though, that this address belongs to the default environment, which is going to be this config.yaml. So flip on back to the terminal. Watch this. We're going to do ---- to specify the parameter here, named -addresses, space. Then we're going to copy this advanced to-do list address, paste it in right here, set it equal to default. So I'm going to press enter right there, and it actually goes through the compilation right here. Okay, great. See this? This is that address that we generated, and then here's the module that's going to own that address. You can confirm this. Look, 11C8C, right? That's the starting. Look, flip on back, go to the config.yaml, 11C8C, right there. That default came from the Aptos config.yaml file. So that's where this module is going to live on chain, and that's important for when you actually want to call the functions inside of it. You'll see again. You want to make sure that there's not going to be any issues with this by running Aptos Move Test. So I'll type test and use the same named addresses as above. So it'll run here, and it will succeed, hopefully. You'll see it's testing. There's several tests inside of it. We all got pass, no failures. Everything was a success. So now what we want to do is we want to publish it to the blockchain and get this module alive. Let's go to Aptos Move Publish. Same drill again. Named addresses, advanced to-do list address, and default. Give it a run. It'll publish here in just a second. It's going to ask me, do you want to pay to get this published? We're going to say yes. I'm going to type yes right there. Press enter, and boom. It executed the publication of this module that quickly. Now notice the sender is that particular address. I'm going to copy this address and I'm going to show you something really cool. Let's go to the Aptos Testnet Explorer. I'll just go to Aptos Explorer right here. You can set this to testnet from this dropdown if you want to, like that. I'm going to paste in this Explorer. It'll take a second to actually find it. We'll give it a click. And now look, right here, we can see transactions, coins, tokens, resources, modules. There's the module that we just used, that we just deployed. Pretty cool, right? Now, what you might not have noticed is that this is actually a module explorer where you could test it out yourself right here. See, this is actually easy to overlook. These important tabs right here. If I were the UX designer here, I would make these a little more bold so you can see the outlines. This is the code view, but you could actually click on the Run tab here and choose a function and choose things like what signer account do I want to run this as and test it out as. And it would actually run the selected functions. Same thing with the view functions right here. We could pass in the arguments and test them out right here in the Explorer. It's really cool if you ask me. But of course, we can also do this directly from the CLI, and this is where you'll start to see quickly what it's like, why we understood the importance of the structure of how to find this particular code on-chain, as well as how to read the underlying code and see how it works. So let's flip on back to my terminal here for a second. Whenever we want to call a write function, we use Aptos Move Run. That's different from whenever we want to call a read function. We specify where this function lives by typing -- function ID. And in my case, I know we have the account. That's where it first lives. So I'll put double quotes, account, : then the module name. So that was advanced _ to do _ list _ ADDR : then the function itself. So if I flip on back here, go to the run section, I know I want to start with create to-do list to create my to-do list. So we'll say create _ to-do list and close my quotes like so. I don't have to pass in any other arguments because the sender, which is going to be my public and private key combo identified here, is going to be the one who's signing this transaction and sending it in. So it'll be creating the object for this particular sender. So let's go ahead and flip on back, press enter to run this function. It's going to prompt me, hey, like, do you want to pay? Uh-oh. I think it's because I forgot my 0x here. Let's go ahead and specify the 0x account instead of just the 11. Let's fix that and do 0x. Press enter. Oh, no, wait, duh. It's because I used the default method here instead of hard coding the account addressed. So we'll just go ahead and set this to be the default advanced to-do list ADDR. Oh my gosh, you guys, it's because the module name is not ADDR. It's just advanced to-do list. What am I thinking? So I had the right address, but I had the wrong module name. Look at it on the Explorer. The module, look, if I go to modules right here, the module name is advanced to-do list, not advanced to-do list ADDR. So I'll press enter right here to try and run it one more time for sure. Now it prompts me, do you want to pay this transaction to initialize your to-do list? I'll say yes, and the transaction executes successfully. How can you confirm this? Come now back to the Explorer here for a second. Now, one to-do list exists for this particular object. So if I go into resources now and I scroll down, look, there's my advanced to-do list. Here's my user to-do list counter object, and the counter is set to 1. So now what if I want to get data from this particular object, from this particular resource? Well, like I say, we can use Aptos Move View to pull this off. We're going to specify a function ID again, just like we did before, but this is going to reference a view function this time. So instead of using Aptos Move Run, we're using Aptos Move View, and instead of hitting create to-do list, looking at my view functions, I'll go to modules, view. I'm going to do something basic like get to-do list counter. So we'll say get to-do list counter. Now in this case, this one is expecting an argument. See, check it out. If I go to get to-do list counter, it is expecting an address. So the way we use the CLI in this case is we're going to specify args. Then we say it is expecting a type of address, and the value for that address needs to be a resource or a public key. So if I grab the deployment resource right here and press enter, it doesn't cost any gas to do a lookup, a view lookup. And sure enough, it does return to me a successful result of 1, exactly what is on chain. So there you have it, a pretty interesting journey into taking a quick look at how you can get started working with Move, developing modules, and understanding just the basic flow of how things stitch together, especially how to compile, publish, and interact with modules on chain. All right, thanks for stopping by, and we'll see you in the next one.